Okay, well, I think we'll probably move on to Naarea, which is a French company, one of the more recent arrivals in the molten salt community. But David Briggs, who's presenting, has chosen to talk in English today. So David, over to you for talk about Naarea.
Thanks, John. Can first of all, can you see the black screen and can you hear me? Fantastic. Yes. So the second thing is I'm David Briggs, but I'm actually very French with a very Anglo-Saxon name. So and if you doubt about that, I can switch to a very French English accent and you'll understand I'm really French.
Merveilleux.
So John speaks better French than I speak English, actually. So before we go further, who's David Briggs? I'm actually in Naarea helping the company in its development, and that's my role today. I've seen a lot of very technical presentations. I'm not at this level at all. What I've seen is actually quite interesting because it complements quite a lot what we're going to try to present. John spoke about values, financing, and planning. I think that's will be less on the values in terms of numbers, but more on the values about what values are we providing to the market. To do that, what I would like to do is to start to go through the why in Naarea, how did we start and where we're coming from, and why we made the technical choices we made here. So hopefully you can see Naarea now coming up. So just to come back on why Naarea and what came up. We all started thinking about, you know, this planet and what was impacting the planet right now. We all know, and I'm sure you all know, that 73% of CO2 emissions come from energy production and consumption on the globe. So if we go through those figures very quickly, you'll see there's a various numbers of things around that, but there's industries, transport, buildings, and that's really when we started to think about what we wanted to do and how we wanted to impact that and how we could impact that. So CO2 emissions is important, but it's not the only thing about the environment. So what we decided to do is really to focus also on what about the other 17 SDGs that were defined by the United Nations. And if you look at those, energy is number 7. And this number 7, we believe, is absolutely core to enable the others. So I'll give a stupid, simple example, but there's many others around there. The first one, the one I would like to take is around water. So if you think about water, there's a lot of fossil water, 700 meters below the earth, that is available. It's water we know how to treat to make it available for mankind. It would have it's in very large quantities. It would enable us to save the waters that we have at the surface and therefore improve a lot the environment. So we could live only with those fossil waters. We know how to get them, we know how to treat them, but today we can't do it because of cost and impact of energy we need to do so. So if you go around the 17s, I will not cover all of them, but basically we also realized that energy and this affordable and clean energy is absolutely key for the other environment. So once we spoke and focused on energy, we said, what do we need to do? Well, in fact, we need to solve for what is called the energy trilemma, which is the World Energy Council approach. It means energy that is safe. It means sustainable and environmental friendly energy, and it means equitable energy. So an energy that is available for everyone and at the right cost. So those 3 things were the 3 axes we've been working on to try to solve for that. Today, a lot of the different types of energies respond to 1 or 2 of the dimensions, but never to the 3 of them. There's always an issue with one of the dimensions. So what is Naarea? And let me go through what it is, and then we can cover the few topics we discuss around value, financing, and planning. So Naarea is in fact combining 3 things: a unique technology, a unique industrial approach, and a unique business model. I think that's what we need to focus on, and that's what we would like to focus on. It's not just the technology's core, but those three elements are absolutely key for us to develop. The technology is around XAMR, so extra small or small molten salt fast spectrum reactors. It's going to be produced in large series because we're speaking of 40 megawatts container size cores. And it's around not selling the energy or selling the technology, but it's selling as a service. So we're not going to sell reactors. What we're going to sell is a service, an outcome around that. So why those three things are very important? Because John spoke about planning and financing. Well, in fact, if you look at this triptych, it's very important because the way we're gonna plan for that and work on the development of the project is not to work in sequences like that. So usually you start with your design, then your production, and then your operating and maintenance approach. What we're going to do is work in parallel. So it's working around making sure that from the beginning, we start to integrate production. From the beginning, we speak about operating and maintenance, the offering, the social acceptability. And it's about teams. To enable that, we need to have the right people right now from the beginning. So for instance, we're currently working on integrating people coming from higher series production in the teams right now. We're in the design phase. We've got 60 people around working for Naarea, but that's basically also where we're starting to integrate. We're also integrating people for operating and maintenance at the beginning. Of course, safety security is an ongoing process in terms of planning. And then in terms of financing, I think that's something that's very important. The trick today for us is not financing and finding the finance, it's about finding the right financing. So what do we mean by the right financing? Of course, it's about funding in terms of making sure it's good funding, it's sound funding, but it's also about the spirit and the type of funding we get. For us, for instance, we want to focus on people that have a mindset where they're investing in the future, they're investing in something on the longer term, they're investing with their hearts. So we have decided to focus on family offices, make sure we had partners that will accompany us and help us throughout the next 5 to 10 years, because that's what we want, what we need, and what we want to do. So once again, financing is less of an issue by itself. It's more about making sure we have the right partners coming in and making sure that we're not diluted. We've got a key set of numbers of key milestones. The next one for us is this digital twin, a digital twin of the core, of the heart of the reactor. We're looking at a prototype in year 5, a pre-series and commercial launch by year 7, full series by year 8 with full O&M, operating and maintenance. We'll come back on the offering a bit later, then make sure we integrate after that as a continuous improvement, the return of experience. So those are the timelines we have in mind. They can seem to be challenging, but I think the core thing, once again, it's because of integrated teams, integrated planning in the same spaces that we're able to do that and to move fast on the project. So let's look a little bit more at the values we can provide, combining those 3 dimensions together. So first one, of course, because it's nuclear, it's got to be carbon-free. It's ultra safe and secure. I've heard in the past presentations that we spoke about that, so we'll come back a little bit more in details. It's waste to energy. That was just a previous presentation, quite interesting. Very similar topic here. It's going to be reliable, and we'll come back on why reliable with large series. It's going to be fast, flexible in terms of deployment, and it's cost effective because of the size of the series. It's sold as a service, and therefore it's speculation free. Today we see a very high speculation on the electricity market, and it's mainly due to speculation or the high prices in the market. It's going to be fair, shared, and abundant. We'll come back on how we want to do that, and what we want to make sure is we drive through the business model resilience or sovereignty, depending on how you look at that. So let's go quickly through this. if we look at the topics we have, so because it's nuclear, of course, it's CO2 free. It's very high energy density. I think everyone knows that here. Molten salt, we've heard that in the past presentation. The safety profile is absolutely key, interesting. It helps to simplify, but also to be safer. There's no water, and there's limited pressure in the system. It's extra small. We're speaking from 30 to 40 megawatts. It also is safe and secure because it's a smaller investment for by reactant, by container. It's the right market size, so we know it's also safe in terms of deployment because it's the size of the industry. 40 megawatt is the size of the biggest ships. It's what you need in most industries, and if you need more, you just combine them. It's safe because it's also distributed. You can argue on this topic, but the fact it's distributed, it's a lot more difficult in terms of security to attack it. And it's air cooled because of the size, and the size was key for us because we wanted to make sure we had something that could be air cooled. Waste to energy, we had the discussion with Moltex just before. Of course, it's rapid spectrum, and therefore we can recycle the waste and long life waste items. We close the cycle, and as we said, the waste that is left is very limited, and I would say human size or human timing type of behavior. So large series is reliable because if you want to do large series, and we're talking several hundreds and thousands of them, you need to design for manufacturer and design for service, DFX. So that's very important. John knows that by heart because he comes from this industry, but having a failure mode analysis, very structured in terms of product and process, ensures reliability. And also, we're going to have a centralized approach. So it's a decentralized offering, but the production site will be one and only. Fast, flexible deployment. It's modular. So it means that it's going to be very flexible in terms of deployment, ease of maintenance, because it's going to be container size type of modules. We'll be able to rotate them. That's what we call a Naarea. And once again, ensure that we do all the maintenance inside our one central manufacturing and maintenance site. We're going to leverage 3D printing. We already started to work on the material there. It helps to simplify the design and have more compact parts, and we can produce per needs. In terms of cost effectiveness, of course, we've got a scaling effect due to the number and the volume. We can capitalize on our continuous improvement approach in the central manufacturing site, centralize the return on experience, and ease the expansion in terms of cost. Of course, if there's one big central area, you maximize your fixed cost. You minimize, sorry, your fixed cost. When it comes to the business model, Naarea, once again, is a service provider. We're going to sell energy, but not only energy. We'll come back on that in a few clicks. We're going to focus, and we want to focus on CO2 emitting industries. That's our core business. What we want to make sure is we offer, and we have an offer that is based on CO2 reduction and SDG positive impacts. And we want to make sure we focus on those. As we said, because it's a service, we're going to have a model which guarantee a cost over time. We're looking at 10 to 40 years contracts. We offer an energy, whether it's heat or electrical, and it's close to utilization and very adaptable. We can adapt the level of production in a matter of seconds. And of course, we have the full ownership and responsibility of the cycle. And that's what we want to have, is make sure that when we go to an export market, we master everything from A to Z with our partners, but basically have the full understanding of the cycle. So basically, we're speaking about resilient and carbon-free energy as a service. So if we come back on this little graph, just to highlight that we do think we solve for quite a lot of this energy trilemma. If you look at the top part, security, it's ultra safe, secure, it's reliable, and it provides sovereignty or resilience. When it comes to equity, speculation free, fair, shared, and abundant in the business model, and cost effective, as we discussed. And then finally, in terms of environment, of course, it's carbon free. We do waste to energy, and it's very fast and flexible in terms of deployment. And as we know, there's an urgency out there, and that's why we were driven in terms of making sure we could deliver something with the shortest time to market as possible. So if I just conclude on that, because I know we only have 15 minutes, I'm probably a little bit over right now, John. But what is Naarea? It's a 40 megawatt XAMR that will be produced in large series, providing a carbon-free, resilient energy as a service. And this is really made possible because of the molten salt. I mean, basically, if we didn't have this technology, this would not be possible in terms of size, reactivity, impact. And I think the intent of going fast to the market is absolutely key, because we all know there's a huge need of all of us on this call and on this webinar to help saving the planet. And I think there's room for everyone, and there's a solution for everyone out there. So let's go and save the planet.
Yeah, great. Thank you very much, David. Maxime, over to you.
Well, are there any questions for David? Evgeny.
Thank you, David, for your presentation. In your project, you demonstrated the organization of the project as a one line. So one milestone, next milestone, etc. Digital twin 1, digital twin 2, digital twin 3. Manufacturing and so on. But where are the decision-making points and forks if you will face something wrong?
Yeah, absolutely. So there's a couple of things I can answer to that. So first thing, there's the way, and we are organized in terms of project management, right? So of course, we've got a certain numbers of gate reviews, we've got a certain numbers of structured meeting, we've got a weekly cadence, we've got a monthly cadence, and quarterly cadence. That's absolutely clear. We do know we got to face problems. We already face problems, and despite the nature of our organization and the way we work, that we each time we've got a problem, face it as a team with all parties, define on what's the best solution. Is there a way to get around it? And then if not, we move to a B plan. So we have 15 minutes was pretty short to present everything, but we have a set of numbers of what we call technical and production nods, and those we've got all of them. The big risks or the big issues we foresee, we always have a B plan around that. Now sometimes you're right, we need to go to a C plan, right? But once again, I think you're right. The trick is in the way you organize the planning, the team you have, but the way also you get the team together. So that's why we're very specific on all getting together. We're spread out. Some of us, I'm not based in the offices, but from Tuesday to Thursday, I'm in the office, everyone's in the office, and we can work together.
Okay.
We have a question from Cedric. Is the operating temperature compatible with 3D printing? Allow still technology. Allow you. Exactly.
So that's a really good question. It's today we're working on yes, allez-vous régler le problème de la corrosion. That's a good topic. We're working on it, that's for sure. The approach on 3D printing is, so first of all we've got B plans, right? So 3D printing is something we want to target and go to, but there's other options we can take. We would love to go through 3D printing because it helps us in terms of industrialization, of course. And plenty of other things, size, etc. We have started to work on the material, and in terms of temperature, yes, if you use graphene, for instance, or SiC graphene, then you absolutely can be compatible with that. That's a big topic. We've got people working on material, and we have engineers working on that. That's definitely a good question.
Question from Ivan. Why are you going with a very small reactor in order to close the fuel cycle? Is it designed to be cooperated in conjunction with an APR?
So we started from the market. In fact, we said where do we start from the market? So the size of the reactor was designed first of all because of the market size and where we saw a market. Secondly, we also wanted to make sure we had something flexible in terms of deployment, so you can put multiple of them in parallel and get a bigger power. The waste to energy piece is key, first of all, because of social acceptance. So that's the first thing that's very important. Make sure we have that. I'm not sure I've answered to the question, but basically, once again, we looked at the market where we thought was the market, and that's how we went for it.
Maybe very last question, so which is, I think, always the question for molten salt reactor is, did you solve the corrosion problems?
Well, that we're working on that. Yeah, I mean, I can't share everything in lots of details, but yes, that's clearly one of the topics we're working on. It's one of our priorities. We've already started quite a bit of work on this. That's the only thing I can say at this stage.
Thank you, David.